Wi-Fi is a technology which actually brought internet in palms of people.
Today we have our guest, one of the innovators in Wi-Fi space, Shubham Saloni. So for anybody new who doesn't know how the process of patenting works, so can you give a quick overview on how that whole thing works?
Yes, for sure. So I would firstly want to break this into two things. Okay, so one part is there's a legal patenting process, and the second part is your contribution, like your innovation part to it.
You have multiple patents filed. So what's your most memorable Wi-Fi innovation that you contributed or worked closely on?
Lot of different ones. Everything has its own story, but if I have to pick one, I will pick this one I worked on, which was for determining antenna conditions.
What's the translation ratio between IEEE defined spec versus the number of features that are actually being used in real world deployments?
I don't think it's very good, personally.
So if you had all the power to introduce or fast track one innovation in Wi-Fi in today's context, so what would that be?
Yeah. Approach, yes. Towards technology, towards networking. Yeah. Any kind of networking equipment, right? Because usually everything is on all the time and that consumes a lot of power, which is very resource heavy on our earth.
Hey everyone, welcome to Weekly Wi-Fi Wisdom podcast series where we talk everything about Wi-Fi and the tech that surrounds it. I'm your host Sainath. I'm WLAN-Q engineer at Candela Technologies. Today's episode is going to be a special one because we are going to talk about innovation in Wi-Fi, and we are joined by one of the innovators in Wi-Fi space, Shubham Saloni. She initially started her career at Broadcom in R&D department. Eventually, she moved to Aruba, and then currently she is working at Meter, leading engineering and product teams. So I'm glad that she joined with us today in Weekly Wi-Fi Wisdom podcast. Thank you, Saloni, for joining us. And I'm looking forward to hear from you about innovation in Wi-Fi. So before we dive in, I would like you to introduce yourself a bit to our audience, and then we can get started with the episode.
Yeah, absolutely. First of all, thank you, Sainath, for this opportunity, and I'm super excited and glad to be here. For me, I spent more than a decade now in the Wi-Fi industry. As he mentioned, I started with Broadcom, so I worked on the client side of the technology that time. And then I moved on to Aruba, where I worked on the infrastructure side, on the access point. And anyone who knows Wi-Fi knows that both sides are equally important for you to have a good experience. So I'm very glad I got that kind of opportunities in my career to understand the whole ecosystem. So after Aruba, I moved on to Meter, and right now we are doing full stack. So it's super exciting, and I'm very glad I'm here.
Yes. Let's get started. So Wi-Fi has been a very important technology in the world. If we see today, almost everybody are reliant on the technology. So it's been well over for more than 25 years. So in your view, if you have to pick one feature that's the most innovative in Wi-Fi that sits on the top, so what would you pick?
If I had to pick one feature, right? It's such a difficult question to answer because there are so many good features in Wi-Fi, and everything is there for a reason, right? Like why we thought about that feature making sense at that time. So I'll take a different approach in answering this question, and we'll just like to take a step back and lean more into your words of saying that this is a old technology, right? It's been around for 25 years. And if a technology has been around for that long, it's a clear indicator that it is helping people. It is solving a very important use case, right? And the, yes, exactly. And this, I'm gonna share an anecdote. I had like a very small meeting with Dorothy Stanley. So she's very like closely involved with like IEEE 802.11 standards. And in that conversation, this came up that Wi-Fi is a technology which actually brought internet in palms of people. Because if you think about it, before Wi-Fi, it was only Ethernet. Everybody, if you needed access to internet, you needed wire. You had to be, seated. You had to be in one place. Or if you would move around, you would be moving around with like long Ethernet cables. So Wi-Fi gave you like true roaming experience, true, like moving around and having like internet in the tip of your hand. Before we around that time we also had like cellular was there. It was also wireless, but it is a paid spectrum band, so it's pricey. But Wi-Fi also uses free ISM spectrum band, so you do not pay for Wi-Fi itself, like using that band. You just pay for your router or your ISP. So this was such a huge unblock. So overall, it's been a technology which has evolved and like continued to weight itself through the years, and is still like super useful and is the one which truly made networking ubiquitous. Everybody can now access internet, and Wi-Fi plays a very key role in it. You would hear things like that, right?
Absolutely. Wi-Fi enabled internet access to many people, as you said. It changed the world.
Yeah, and I think you and me and
Yeah. So
people are like we're part of this awesome industry. I would just say that. Yeah.
yeah. Right. So when we are talking about innovation, if we look at Wi-Fi 6, Wi-Fi 7, we are seeing numbers like 10 Gbps plus throughputs, and you have ultra low latency, and Wi-Fi 6 specifically focused on efficiency as well. So, in general, what drives innovation? So, what factors typically drive the innovation and the way it gets in that direction?
Yes, for sure. So if you think about the whole evolution of Wi-Fi, right? Like BGN, then you've got ACAX, now Wi-Fi 7, BE and BN, right? Wi-Fi 8 and beyond, perhaps. Um, so the initial ones, right? BG was the technology came in. We had only 2.4 gigahertz band, only three channels, but it worked, right? It was a huge hit that time because no more wires. But I still remember like my first job when I was at Broadcom, we were working on a 11N chipset. At that time, my desk had a wire. So my usual day work I used to do on an Ethernet, not on Wi-Fi.
Oh,
That was 11N times. Okay, that was 11N times because speeds were not, that great. So I think a lot of innovations during BG, CCK, OFDM, like a lot of fire rate improvements and all of that happened. With 11N came in like 5 gigahertz band. That gave the bigger spectrum, right? Having more channels gave a huge unblock there. I think then there was like a lot more adoption, right? Like people started having like actual Wi-Fi experience where access points would be there and you can come in and you can just bring in your laptop and work over Wi-Fi. So that 11N got an aggregation, better throughputs, all of that. Um, then with AC, sorry, aggregation around came in around AC. Yes. So Wi-Fi 5 was truly like a good unblock, gave you like a good amount of like VHT, a very high throughput, focused on throughput mostly around that time. You got MCS rates and all of that. So this was kind of an evolution, right? You started out and then you're like starting to improve on speed because that's the most key important thing. Nobody would want to press a button and then wait, right? When you have an option to, like take a wire and just do your work. So that was a very key important thing. After AC, this was such a huge unblock that the number of devices exploded, right? There were like so many more devices, and there's only that much spectrum. And Wi-Fi is so what is it, democratic? It accepts all. Everybody gets a chance, right? So with that, any slow device can slow other devices, and a lot of like those kind of things started kind of coming in, and that was a key innovating factor at that time that let's address the density problem. Right, there are more devices, which is a good thing. If something is being useful, more people use it, but as and when more people use it, then there are different set of things which you need to focus on. So that was the density. So Wi-Fi 6 was mostly focused on solving density, and then like EHT, more like you have MLO, you have 4 gig QAM, 320 megahertz. Before, I would say Wi-Fi 7, a bigger unblock was 6E, having 6 gigahertz band, another like huge spectrum space. So all right. Similar to how people felt when they had like 2.4 to 5, was like, oh wow, we have like all this. So now we feel like that for 6 gigahertz. Yeah. So 6 gigahertz came in. So it's been like uh, a journey through the use cases which has evolved over time. So I would consider that
Right.
these have been kind of the contributing factors on what people want, how people want to use it. And based on the usage pattern, we have innovated on top of it on, okay, these look like the most key things we should solve for next.
Right. So Wi-Fi is absolutely looking into the real world use cases based on the number of devices that are growing. It accounted for efficiency, and then now again, I think we have AR, VR, and heavy applications demand that is growing, and Wi-Fi 7 is addressing that. And who knows what Wi-Fi 8 is going to address?
And
I think lots of innovation is going to be there for sure.
yeah, Wi-Fi 8
Reliability. Yeah.
reliability, because end of the day, this is wireless. There will be packet loss, all of that. So how can you run any critical thing on it? Yes, maybe in future. So yeah, things are evolving that way.
Yes. And yeah, while introducing you, I didn't mention about your patents. So you have more than 10 patents in your contributions, right? And you also made lots of publications. So for anybody new who doesn't know how the process of patenting works, so can you give a quick overview on how that whole thing works?
Yes, for sure. So I would firstly want to break this into two things. Okay. So one part is just a legal patenting process, and the second part is your contribution, like your innovation part to it. So if we just talk about the legal aspects of how patenting thing works, I'm not a lawyer, so I will not give you a very deep answer to this. Um, but essentially, like most companies have a patent lawyer. If your company does not have one, talk to your leadership. They should be able to help you through the process. The way you would work inside a company is, once your idea is a bit ready, then you just like collaborate with them, and then they work on your case. The case gets set and done. And once it's filed, my suggestion would be forget about it, because it's a long process. Uh,
Oh, okay.
yeah. Forget about it, as in you can remember that you filed one, but if you kind of become impatient on what's happening, then usually this is a time taking process, and on an average it takes about like a year and a half to for you to see something happening on it. And so the states would be, you have filed it. Initially it would not be published. It's still hidden. Once, I think, after there is a cool off time, it will be published, and after that, if it's been approved, then there is a grant. But all of this kind of takes time. So this is just the legal aspects of the patenting process, and a lot of viewers in this channel are people who directly work with technology, right? If you're a lawyer and you're here, then you're not on channel. But of course, so if you are working with the technology, right? So this is the second part of my answer, where how to approach it. So before I give my answer, I'm going to ask you a question. Okay. And my question is,
Okay. Sure.
how much experience do you think someone should have in the industry before they can, start any meaningful contribution towards this?
Towards
Yeah.
patients, well, I'm not sure.
Any top
Uh,
of your mind?
I have no idea, to be frank.
Okay, pick any number. Which you,
But if I have to take a guess,
yeah.
yeah, yeah, if I have to take a guess, probably I would say maybe 8 years. It's just a wild guess.
Yeah, sure. But if you think about it, 8 years is almost like you've spent good amount of time in the industry, your mid career, right? So 8 years is in that range. So even if you would have picked something, so it definitely is in the like higher side of your work experience. I would like to tell you that my first patent I filed 2 years into the industry. I was only 2 years experience in the industry. So that's the myth I just wanted to talk about first. Okay.
Okay.
And it is not like,
So there is no such thing as years.
no, it's if your idea is good, and the lawyer, because lawyers know the process, they can figure out if anybody has already filed it, and there's like all of that. So I'm not getting deep into that part because the other part is more relevant to the audience here. So if your idea is good, you can, and the lawyer has approved, then you can always go for it. So that is the first myth, that you need to have like spent a lot of time in the industry, then only you can even start thinking about it. Okay. So I would definitely encourage, if you are in this industry and you love the technology, love like learning about the technology. This is like a lot of things to learn. So that's a good and the bad part of Wi-Fi, right? Because once you know, it's fun, but before that, it's like, oh God, what is this? Like packets are going, so much things are happening, and that can happen, this can happen. So it's a lot going on in a Wi-Fi network, and that is what makes it like such a good ground for you to think about what things can be improved. Okay, so the first myth which I'm busting is, it's not that you need a ton of experience with this. So essentially, I will break this down into three key things which you can think about. First part is just the technology itself. At least you need to know basics. You need to understand what's happening. And here, when I say that, I'm not coming in from a expert thought process, right? An expert knows like wide variety of all different things. But suppose in your career you're working on a particular problem, right? Maybe you're working on aggregation. Let's just pick that. Okay, aggregation, the packet being aggregated, being sent, you're getting like acts and all of that. So you're working on that part. Understand that well, right? Understand that part well, because you're working on that one part of this whole big puzzle. Once you understand that well, you can also like, then you will be also be able to figure out a little bit on how like a client device would be using it, how an access point is using what, where are the places where this can fail, things like that. And when you so it's just that much. Okay, I'm not saying that you need to do a PhD, but try to understand whatever problem you're in. So that would be the first. At least you need to understand, because it will be like, yeah, fine. First thing, you need to understand any problem which you're solving in the big puzzle of Wi-Fi, how, what's happening, things like that. Once you have fair understanding, second part I would suggest is, many times you kind of get into the trap. Okay, that's a big shiny project, lot is happening there. If only I worked on that project, I would have done more innovative things compared to my this one boring thing. No. So have that approach, that anything you work day to day, uh, you may find interesting problems, who knows, right? So always like try to go a little bit beyond, try to go a little bit beyond on whatever you're trying to solve. um so the first one which I did, right? I do remember there was so, because Broadcom was a chipset company, so I used to like work on directly implementing the protocols. And there was something with aggregation I wrote, and then there was like, while working on it, I remembered there was this whole edge case, and I read the standard, and the standard wasn't like that clear. There was no like clear definition on how this should work. And then I started thinking about all the edge cases. Um, and then from there, I figured out, okay, if we do this, this is going to be like a more reliable way of doing things. And to be frank, when I filed for that, I did not think it had that much merit, but it did get, like at least Broadcom approved it. So day to day, right? It was not like 2 years into my career, I was getting like awesome projects or something like that. But anything which I was working day to day, from there itself, I was, like leaning into some curiosity, trying to do some more experimentation myself. So things like that were helpful. And even throughout, like a lot of ones which I did at Aruba were like similar pattern. Like, although I was like doing better projects, but similar pattern. Whatever I was working on, I was also like thinking more on, oh, is this secure? Is this reliable? Can I make this better? Things like that. So you do not need like too much time. Second part was the day to day, right? You do not need like very shiny things. It does not need to be groundbreaking, first in the industry. It does not need to come with all those shiny titles. It's in your boring work. It's sometimes in your it's hidden in that curiosity of why did this happen. So so lean into that. The third part I would say is work with people, do some brainstorming, because at times if we work by ourselves, we may think in a certain way, and when you talk to different set of people, that may spark some newer ideas. So that those kind of things are also useful. And when I say this is not only you talk in people in the Wi-Fi industry, talk to people in different industry, right? How if they are applying something and they sort thing in a different way, oh, can that approach be brought in here? Those are also different ways of like sparking some creative thoughts. But that will it's just that you will have to develop that brainstorming thought process. It's not about I'm right or I know more, or I'm here, I'm learning is always there, whenever you're brainstorming. But it's also like, okay, let's see if we find anything good when we do this brainstorming, right? So a lot of uh, yeah, a lot of like good ideas come from there. The first one which I did, right, it's not approved. I would also be very honest there. So the first one which I tried was not approved, but it was, accepted by Broadcom to be filed. So it wasn't approved, and that was a pattern I did by myself. It was only my idea.
Okay.
It like brainstorm with anybody, did not collaborate with anyone. That time I was also very new and did not know. I just knew something like this exists, and I was like, okay, let's see, and then got approved, but it did not get to the final approval. And that time I discussed with some more folks, and I got this feedback that yes, it's always good to have more minds contribute and make a good idea solid. So from then onwards, anything I
Yes.
worked on, I've always worked in a group, and you brainstorm with different sets of people. Some will stick, some will not, but you will eventually find your tribe. I hope, and I wish for all of you to do that. But if it doesn't work, also then you got like good brainstorming done, right? Which is always like nice and fun, and you learn something new.
Correct.
Yeah. So to cap everything
Right.
down,
Very true.
yeah, three things: technology, problem in your day to day. Try to have that mind, and then work with people. Do some brainstorming.
Yes. Uh, Thank you for sharing that wonderful perspective. Now, uh, here is a personal question. So, you have multiple patents filed. So, what's your most memorable Wi-Fi innovation that you contributed or worked closely on?
It's a good question because it just sparks so much good memories for me. A lot of different ones. Everything has its own story, but if I have to pick one, I will pick. There's one I worked on which was for determining antenna conditions. So the idea was around if you have an access point using software, can you figure out if there is a problem in antenna? And this actually came about because I was once in an escalation. I was part of the engineering team. I was working on the Wi-Fi AX access points. So only when it's a highly escalated case is when like engineers used to get involved there. So that time when I was working with a customer, we had to like get the access point working, and all that is in a bit of stressful situation, and usual debugging, right? Like you will start with taking packet captures, checking how packets are happening, protocol level, if there are drops, things like that. And it was just like so confusing. It was not narrowing down to anything. And the debugging was just so difficult, and that time I just kept thinking on what could be happening, and you trying all these different options. And that time I played a little bit with chain mask on disabling a few antennas and just checking like how this works. Also, I think this came in because we were also trying to isolate, is it seen on more APs, less APs, and all of that usual debugging thought process. Um, but then with that, eventually we could find that there was like this was one bad AP we could submit for an RMA. It would be replaced and all of that. But during that time we need to continuity. So I just like changed the antenna mask, and things were all stable and all good. Ideally, I could have just like moved on, but I that one like made me thinking a little bit more because it was such a huge waste of time for people. I felt that, right? Because it was in it. And it's like, if an antenna is bad, people may actually like just try so many different things eventually to come there. So that should actually be one of the first things that you should be, it should be easy for you to check. And then I think so
Right, right.
so this was this is a bit memorable because I think the my co-authors for this one, I had like a lot of fun like coming up with the whole idea on how you can use software to determine this. And inside HP, we used to have a technical conference, which is a bit competitive to get into, and this got in there, and then I presented in TechCon. So yeah, a lot of like good things came out from this one, and the impact, and I'm
Yeah.
the impact with this one.
That sounds great. Sounds like a great innovation, truly. Now, so when we talk about innovation in Wi-Fi industry, who are the main stakeholders that push the innovation? So we have IEEE, the standard body, and we have the chipset makers. So who are the main stakeholders that push the innovation forward?
So it depends a lot on what part of the industry you're in, right? Because you're part of testing equipment, right? That's your role in the bigger industry. Then the chipset vendors are making chipset. Then there are vendors who are, making equipment. They're buying the chipsets and putting in their like client devices or infrastructure devices. Um, so I think everybody plays some role for sure, because together everybody is pushing the industry forward. And particularly, I have huge respect for organizations like IEEE and Wi-Fi Alliance, because the interoperability is so important, right? Someone makes something and someone else, and they don't work together, you have a bad experience. So everybody plays their role, which is important, and everybody is, together contributing to, moving the industry forward. And uh, particularly for chip vendors, they do work a bit like ahead of the market. So they generally, I have seen like they have a bigger say inside of how the standards get shaped and things like that. But despite that, um, I still think that anybody who contributes does plays their role in making things move in a in a forward manner. So yeah, stakeholders are there, and not like everybody may actually think about how they have implemented, and if this can work well with their implementation, or things like that may happen, may not happen. But also like a lot of innovations companies also do on top of that, like what's already in IEEE. So everybody contributes to it, whether they are directly involved with standards or not.
Right. So now let's talk about the role of spectrum in Wi-Fi. So as you rightly said, 6 gigahertz opened up a lots of opportunity.
Yeah.
So there is that excitement whenever new spectrum is being allocated to Wi-Fi. So how much role does spectrum have in enabling innovation in Wi-Fi? So let's say if we are going to get another band of spectrum, what kind of innovation are we going to see? So what's your take?
So it would. I am I am assuming, and I'm thinking it might be a very similar thing to what happened with 5 gigahertz, right? It did unlock a huge, um, what to say, like a use case, because 2.4 gig was there. It was working. People were, it solved one use case. Then 5 gig brought in like a new use case. And now that became office spaces, like a lot of enterprise spaces were unblocked. With 6 gigahertz, it's going to give you like so many more channels. And uh, C20 megahertz may become a reality, like very deployable solution and all of that. So a lot of time, like innovations in Wi-Fi spec wise, Wi-Fi 6, Wi-Fi 7 are very like physics theoretical based on, or we have done channel bonding. So, throughputs are higher and all of that. But many times that doesn't translate directly to a real world, because spectrum, right? Who is going to deploy 160 megahertz on 5G? You can, but why would you, right? So things like this is always efficiency multiplier. We'll only I'm very excited about this, and it's definitely going to open up like newer use case, and yeah, lot of like exciting things to come with the new band.
Right.
Yeah, even like MLO, right? The key unlock is when you have 6 gigahertz in the mix.
Oh, right, absolutely. Yeah. So I think this question is what I'm looking forward to very much in all the questions in the list. So IEEE comes up with lots of features, thinking about multiple use cases in mind. So there are n number of features that gets implemented in the spec. So if we take the latest 2024 IEEE spec, I think it's around 5,000 pager or even more.
Yeah.
So there are lots of features that get implemented, but how many of them are actually translating into practical use case? What's the translation ratio between IEEE defined spec versus the number of features that are actually being used in real world deployments?
I don't think it's very good, personally, because Wi-Fi is in general a bit complex technology because it's not only infra side of things. You are a Wi-Fi 7 access point. All your client devices are, a mix of 11N, 555, Wi-Fi 4, right? So you have all the newer, you can do that, but the other end is not supporting it. So an unblock can happen for Wi-Fi only when both ends support that. Both are Wi-Fi 7, you get benefits of Wi-Fi 7. Also, in Wi-Fi, there is so much variability environment, whether antenna orientation or that packet loss has happened more because humans were walking and they absorbed the signal, or there were like metal and there was reflections, right? Like a lot of different things could be happening in any kind of environment, right? So it's firstly like the technology itself is a bit complicated and you need both ends to match to get it. So that's the first part, which is only technology. Okay, I particularly think that in the industry, because most vendors sell hardware, they focus more on the hardware winning spec. So, specs
Oh,
should
right.
be like top notch specs, and it should be all amazing and all of that, right? And all the testing they would do in a RF chamber, and it will be in a lab, and you will have like very high amount of throughput numbers which comes in, right? So physics has worked because you were in a isolated environment, but real world can be much more complicated, like I mentioned, right? So that itself is a mismatch, right? But when in the industry, the business model, majority of the players have a business model where you're selling the hardware, then you're selling it based on, these kind of different features. So a lot of pushes on that, oh, let's make this work, let's make that work. Although nobody is actually thinking about whether someone will actually use it or not, right? Because a buyer is also buying, okay, yeah, this is going to improve, or throughput is higher, density will be good. Um, but really in the real world, did it translate? Maybe not. And the industry has a lot of players who make amazing products. I have a lot of respect for everybody in the industry. Like the access points are like very performant, have like good hardware, all of that. Um, but you deploy it wrongly, right? So you have the best of the access point and you deploy it behind a metallic pillar. No one's gonna get any Wi-Fi. So things like that, right? So that's another thing. When you're selling the hardware, what happens is you sold the hardware and you moved on. You are not the one who is deploying the hardware. You have no idea how the real users are interacting with it. What are the actual problems and cases which are happening? So this disjoint exists in the industry,
Yeah.
which I think is right now one of the reasons why not a lot of innovations get directly tied down to a real actual real world outcome.
Right. And um, adding on, so IEEE, when it releases a spec, so it only mandates a few features and keeps few features as optional, right? So some vendors might go implementing that, some vendors might not implement that specific feature, which may lead to interoperability issue.
Yeah.
So do vendors generally speak to each other saying that we have to get this feature implemented? So such kind of communication, do they happen?
So this is more on why the Wi-Fi Alliance and the interoperability test beds and things like that are there, because think about it, right? If you are a vendor and your device is not working with the clients, or you're a client vendor and you're not working with major access points, then it's a problem for you. So everybody is motivated to solve the interoperability problem. That's a technology problem, which also ties into the whole backward compatibility part, which I said, right? This is similar. Some vendors may not have done the optional one. It will still work because Wi-Fi is reliable like that. Because even if you don't have it, it will downgrade and give you a bad experience. It will still work. So yes, I think lot of inter company collaboration does happen in like, I think there is I forgot the name though, but there is a testing event which happens where like everybody comes in, they test and they will fix, everybody will fix. Yeah, things like that.
Yes. So now, when we are talking about innovation, let's see what Wi-Fi already achieved, right?
Mm.
So we have speed, where we have 10 gig plus of throughput already being achieved in right conditions, and we have low latency that is in focus with Wi-Fi 7, be it MLO or other features that are contributing to get the latency down. So, with all these advancements, do you think we are hitting a saturation point? Do you think the innovation curve is flattening uh, in the coming future?
Personally, I don't think so, because
Okay.
more use cases can get unblocked. It's more like that, right? Because right now you may think about, yeah, we can have like good throughput and all. Maybe office spaces are good, but let's talk about places where there are a lot of robots, or places where there are a lot of IoT devices. 2.4 gigahertz is there, which is supporting them, but maybe there's like still things which needs to be done there to make them better, make them more reliable, make them more secure. So as and when I think the technology improves, the use cases improve, and then there is always like scope for making things a little bit better, performant, reliable, secure, and that the cycle continues. So I do not think it will plateau. There are definitely certain limitations with respect to physics and things like that, of course, and I think those things will happen sometime eventually in future. I am like 10, 50 years down the line, maybe, but maybe by that time we'll have newer use cases.
And do you see the innovation gradually moving away from Mac and file layers to more on the software and network side of things, on how the Wi-Fi is being deployed and how it is being managed?
Okay. To answer this question, I would like to do a thought experiment, which is just think about who are the end users here, right? End users, let's just consider an office space. People who are like, if I am a chipset vendor or I'm like doing client side of devices, it's people who are directly using the devices, right? That's your end user. For infrastructure, your IT team, the admin or network team who manages the network. Think about this, right? Those are the people who are also using like iPhones, they're using like better kind of hardware in day-to-day life. And then they go back working on a networking equipment, and then they have to log into a CLI and they need to remember like all these, obscure commands. So there's such a like mismatch,
Yeah.
right? And everybody likes ease. For them, it would be better if they could support a stable network, right? That's what people would want. Like, my network is stable, people are able to work, they have better throughput. If you have, do you have need to have Wi-Fi 7? Absolutely not, because if most of your devices are Wi-Fi 6, or you are in an environment where Wi-Fi 6 throughputs are good for you or is enough for you, there's no need for you to upgrade, right? So things like that. So end of the day, right, like that end user does need some ease, and they need peace of mind. And thinking that, now let us tie it back to your question on, do we think there will be more innovations in software side, or like AI driven optimizations and cloud based management. All of these things are together making this easier for the end users. because Wi-Fi itself is a complicated technology. Like I mentioned, there could be a lot of factors guiding different things, and if something is not working, a lot of different things could be broken. A lot of time, it is not Wi-Fi; it could be your wired layer, but Wi-Fi gets
Absolutely.
all the time.
Absolutely.
Yes, so Wi-Fi gets blamed
Wi-Fi gets the blame.
exactly,
Yeah.
and I think oh yeah, there was a meta demo also recently where Wi-Fi got blamed, right? So
Oh, yeah. I remember that.
yes.
Yes.
So if you're professional working very closely with the Wi-Fi technology, you are by now you're like 100% sure if something doesn't work, everybody is gonna blame the Wi-Fi. Um, so in that case, the whole part of optimizing or finding in like key observability things to debug it better. What's happening, what's not happening, how you can ensure that the network can work well. So this whole thing is driving a lot of autonomous networking and things like that. So there will definitely be more and more innovations on that side because people and the outcomes they want are aligned in that way. And Wi-Fi is complicated. So instead of you would do automations earlier, and then already there are like 50, like data points on which you need to make decisions. Even channel optimization, right? Like there's so many different factors which you need to take into account. So then you could add like ML base, and AI is a great tool, but it is not good for all use cases. So you can figure out like which places it can be better. So things like that, like it can be very good in answering questions about a network because that context it has. But maybe if you need to just fix something which you know an answer to, like an ML based solution could be better there. But eventually, like the everything getting tied to what an outcome an end person would want. If you are using your phone or laptop, all you care is you are able to browse, you're able to watch this podcast on your phone
Yeah.
or anything else, right? You do not want to care so much about, is this 557, do I have like oh, I'm getting these packets, did it come with OFDMA or did it come with a new MIMO, right? So yeah, so a lot of like innovations will happen in that layer, which is where the industry is going and is needed.
Right. So, um, this is a bit of imaginary question. So, if you had all the power to introduce or fast track one innovation in Wi-Fi in today's context, so what would that be?
It's a interesting question.
So,
Yeah,
y- yeah, you have all the power. Everybody will listen to you on this one. So,
I do think that network is used so much today, right? Everywhere it is being used, but it is also like resource heavy, and it does have a toll on our environment. So things which are like we're talking about Wi-Fi right now, so I'm going to stick with that, right? So um there's a there's a feature I worked on which was not really a feature, it's an idea, which was about very like power aware. You are very aware on infrastructure side. So a lot of like vendors do that, but this is more like um, not only your access point, but all like networking gear and everything, and even your like whatever any kind of networking equipment, right? Because usually everything is on all the time, and that consumes a lot of power, which is very resource heavy on our earth or our planet, right? So I would, if I had all the power, I would probably do something like that because I think that'll be very impactful. And if I had more time to answer this question, maybe I would, yeah, I would have think about something more. But this is what comes, at the top of my mind at this time.
right. So, sustainability
Yeah,
focused
sustainability first
approach.
approach, yes, towards technology, towards networking. Yeah.
Understood. So, probably I can conclude with this question. So, today AI is everywhere, right? So everybody talks about artificial intelligence, and I do think every company is adopting AI in some or the other way. So, uh, in what ways AI is contributing to Wi-Fi innovation that's happening today?
So AI is a great tool, and AI is definitely an efficiency multiplier for anyone who is doing anything. But you need to use it in the right way, right? Because what LLMs did, it can solve a subset of problems really well. but not all the problems. So
Right.
so that information and that understanding is important, and also what is the context, right? Which your model is trained on, what kind of data that will determine the efficacy of the AI which you're using, right? So a lot of these things, because yes, AI is hot in the industry, AI is a great tool, AI can help in many different ways, but does that mean AI should be everywhere? Probably no, but it can be definitely in places where it can add value. And yes, like it has, personally I think that this whole macro language conversation style, right, where it can translate a vague question into very actionable things, or it can break down things, right? So things like that can just make it more easy to find information about your network, debug your network, support your network, or a lot of this like that. So that's one way of finding the, like AI funding is being into being more useful. Other thing is also, yeah, like just AI can be a mix of machine learning. I see, like where there's a huge amount of data, of course, machine learning have got into various sectors there. Where it can find patterns, it can find like all the different things. And this Wi-Fi things are always changing, right? Environment can change. Yesterday there wasn't a blue five tables around. Now the system could look at them, right? The things like that can happen. So how fast did you adapt? Things like that. Yeah, it's going to be it was going to be very useful, but only for people who are intentional about applying it and are not just blindly using it for the sake of using it. That would be my answer today.
Makes sense. Yes. Um, yeah. So we are done with all the questions. So if you have anything to address our audience on this topic, please do.
Overall, yeah, just thanks for the opportunity, Sai. This was a very interesting talk even for me. I am super passionate about, this topic, and especially like working in Wi-Fi, and the whole technology is like super interesting. Like I said, good and the bad part, right? There's so much, but it never stops becoming interesting. So if you are, viewer, and you are like listening to this podcast and you're wondering, or how do I start my journey? I hope if I could be any motivator for that, then it was very good use of our time here. But I just wish you all the best, and I hope to see much more innovations happening.
Yes. Thank you so much. Thank you for joining, Saloni, and sharing all the wisdom on innovation in Wi-Fi. And for the audience, so if you like the episode, please like, share, subscribe, and continue watching Weekly Wi-Fi Wisdom. We'll meet you in the upcoming episodes. Thank you for your time. Thanks for watching.
Thank you.